Hi everybody, today we're going to have a look at how to fill out a trace table when we are doing some white box testing of an algorithm. Now, white box testing allows us to test every path, all of these paths here, through an algorithm. So white box testing gives us thorough testing of a solution to a problem in computer programming. So this is the algorithm that we're going to be testing. It's represented as a flowchart. It could be, of course, a pseudocode, or it could be program code, for example, Python. But this algorithm is represented as a flowchart. Now, this exam question asks us to complete a trace table for this input data. And look at all this input data. What is this input data? Well, if we go back to the algorithm, we can see that there is this input. So this is where, step by step, we put in that test data to test this whole solution. So let's have a look at how to fill out the trace table. Let's see if I can just organize my screen here. I'm going to put this here. I'm just going to zoom out a little bit, see if we can get everything viewable. Can we do it? Can we do it from start to finish? Yeah, let's leave it like that. Okay. Now I'm just going to do this in Adobe Illustrator. So again, please be patient with me, guys, because this is going to take a little bit of time. So let's go to start. Senior is assigned a value of 0. Adult is assigned a value of 0, and child is assigned a value of 0. So that information is going to go into our trace table. So we've got a 0 there, we've got a 0 there, and we've got a 0 there. Next, we input the type. Now, that's where this comes in. This is the input. So the first value that we're going to input is this S. Now, well, let's do that. So this is the first input. Okay. Now, because we are in a kind of we're already gone into a loop here, you will often see that S starts on a new line in the trace table. Okay? Just because we've kind of gone into a loop. This is the start of a new bit of the program. So that might go on a new line. Okay? Experience will help you decide if you need to do that. Now, with this input, we're going to see, is type equal to S? Well, type is equal to yes. Yes, so we update senior to be senior plus 1. So senior becomes 1. And then we just follow the program around. It's going in this direction. Look, there's the arrow. There it is. We input the next type. Well, the next type in the list is also S. So that would go here. That's the input of the next type. And is type the same as S? Yes, it is. So senior becomes senior plus 1. The current value of senior is 1. So the new value of senior is going to be 2. We're just going to work our way around this algorithm using this test data. So we go back around. The next thing we do is input the type again. So we've come to this input here. It's also an S. There's the third S. Is type equal to S? Yes, it is. So we update senior again. The current value of senior is 2. So the new value of senior is going to be 3. Then we go around and we input the next type. The next type is A. Is type the same as S? No. it's A. Is type the same as A? Yes. So we update the adult variable by 1. We increment it by 1. So we're kind of counting here. So adult is currently 0, and the new value of adult, which I'm going to put here, is 1. So then we go up and around, follow the arrows. The arrow is going this way, you can see that there. So follow the arrow around. Input type, the next one is C. So hopefully you're getting the idea of what's going on here. I'm just going to keep going, but if you want to stop the video now and have a go at this activity, please have a go at it and see if you get the same answer as me when you've finished. Okay, so we've input C. Is type equal S? No, it's C. Is type equal A? No. Is type equal C? Yes, it is. Well, we're going to update the child variable this time. We're going to increment it. So child is currently 0, and we're going to update that to be 1. We go around again. Input type, the next one. So there are 2 more C's. So let's see if we can quickly do that now that we understand what we're doing. So we input a C, we're going to update the child, and we do another one. So these are the 3 C's. That's going to become 2, and that one's going to be 3. Then we come around again, we input the next type. This time we've got 4 A's. Well, now that we know what we're doing, let's just see if we can hurry along a little bit. So that's going to be an A. And then we're going to keep going because we've got 4 of them coming in. So with A's, we are updating the adult. So adult is currently 1, but when we input this A, that's going to become 2. Be much easier to hand write this. So apologies. Then it becomes 3. Then it becomes 4. Then it becomes 5. So we've done all those A's. Then we've got W, S, S, D, C, Z. Okay, let's just carry on. W. So we've got a W coming in. W. Input type. Is type equal to S? No, it's W this time. Oh, this is interesting. What's going on here? Is it A? No. Is it C? No. Is it Z? No. So we have to go all the way around to input the type. W doesn't increment senior, adult, or child. It doesn't do anything. Takes us to this selection box, and we go all the way back up to input type. So then we've got 2 S's. So we'll have an S there. And of course we know that S updates senior. So senior is going to change from the current value, which is 3, and it's going to be updated to 4. And there's another S, there's another one there, S. So that's going to update senior to 5. If we can get into that, can we get into that? That's going to be 5. Then we input a D and a C. Input D. Is that equal to A? S? No. A? No. C? No. Z? No. So we don't do anything with that D. We just go back to the next input, which is C. What does C do? Equal to S? No, no. Yes, it increments the child. So child is currently 3. So child is going to increment to 4. Then the next input is Z. And let's see what that does. Is it S? No. Is it A? No. Is it C? No. Is it Z? Yes! Oh look, now we have an output. Right. So we input that Z there. So the output, I'm just going to put it on the next line. I'm not sure if it matters. We're going to output seniors space senior. So the current value of senior is 5. And then we output adults space 5, because adults is also 5, and children space and then child. Child is 3. And that is the solution to this trace table.